Hi, Mike Barr here. Today we're going to talk about
Instruments and Control Loops in the Liquefied Natural Gas Industry, Part 1. The liquefied natural gas, or LNG, industry operates at the extremes of temperature and pressure. The process of liquefying natural gas by cooling it to approximately minus 162 degrees centigrade, which is equal to minus 260 Fahrenheit, reduces its volume by a factor of 600, enabling efficient transportation and storage. This cryogenic environment, however, presents significant challenges for the instrumentation and control systems that are vital for safe, efficient, and reliable operation. In these two videos, we'll discuss the specialized instruments and various critical control loops employed throughout the LNG value chain, from liquefaction to regasification. Let's look at specialized instrumentation for cryogenic service. Standard instrumentation is ill-suited for the intense cold of LNG processes. Materials become brittle, and the accuracy of measurements can be significantly compromised. Consequently, the LNG industry relies on a suite of specialized instruments designed and constructed with materials that maintain their integrity and performance at cryogenic temperatures. One of the key instruments in the LNG industry is flow measurement. There's two ways to measure flow: the volumetric flow rate, which is the flow measured, that's the volume of the fluid only, it contains no other data about the fluid, and the mass flow rate. This refers to the mass of the fluid flowing through a given area in a specific time. It's the amount of matter, regardless of how much space it occupies. Common units include kilograms per second, pounds per minute, and so on. Let's look at flow meters. Accurate flow measurement is crucial for custody transfer, process control, and safety. The two primary types used are the Coriolis and the ultrasonic flow meters. Coriolis meters are favored for their high accuracy and direct mass flow measurement, which is critical for custody transfer as LNG composition can vary. They are constructed from nickel alloys or stainless steel to withstand low temperatures. A Coriolis meter measures mass flow rate and density by utilizing the Coriolis effect on the fluid flowing through a vibrating tube. The fluid's mass flow affects the tube's oscillation, which is measured by sensors to determine both mass and density. Here's an example of the Coriolis effect. We have a loop of water hose. If we start the hose swinging with no water flow, it will just swing. If we start water flowing through the hose, we'll see the hose begin to twist as the direction of the swing and the flow direction of the water conflict with each other. The amount of twist in the hose is directly proportional to the flow rate in the hose. This can be used to get a very accurate measurement of the flow rate. The meter has two loops that are set to vibrating at a certain frequency by a pulsating unit. This is the equivalent of the swing hose. When there's no flow, there's no twist in the lines. But when fluid begins to flow, the lines twist and sensors record the change in frequency. Flow rate is inferred from this data. Ultrasonic meters use sound interacting with the flow of the fluid to determine mass flow rate. And audio emitters send sound into the fluid. Some ultrasonics bounce the sound off the opposite wall. This is the transit time type. And some off the fluid itself. This is the Doppler type. The interference with the sound is directly proportional to the flow rate. Ultrasonic meters offer the advantage of having no moving parts and inducing no pressure drop. Temperature transmitters. Resistance temperature detectors, or RTDs, are typically made of platinum, known as the PT100. They are the standard for precise temperature measurement in cryogenic applications. At the core of the RTD is an arrangement of resistors that respond to the process temperature by regulating current to the industry standard of 4 to 20 milliamps. This current is then scaled to infer an accurate temperature in the controller. Pressure transmitters must have wetted parts made from materials like 316 stainless steel or other nickel alloys that remain ductile at LNG temperatures. They are often installed with impulse lines to protect the transmitter electronics from the extreme cold. The heart of the pressure transmitter is a shape-sensitive strain gauge that changes resistance because of minute changes in the shape or warping caused by pressure. The resulting current, usually 4 to 20 milliamps, sent to the controller. With level measure instruments, accurately measuring the level of LNG in storage is critical for inventory management and preventing overfills. Radar level transmitters are a common non-contact solution, providing reliable measurements without being affected by the low temperatures or the vapor space above the LNG. Differential pressure transmitters are also used, inferring level based on the hydrostatic pressure of the liquid. Finally, the quality of the process material must be established before transfer of custody can occur. That's where the chromatograph comes in. This device measures the types and quantities of different hydrocarbons. From this information, BTUs can be measured and a price per cubic foot or cubic meter is determined according to its energy content. One final word about custody transfer. You've heard me mention custody transfer a couple of times, but I need to underscore its importance. Custody transfer is the cash register of the company. It's where your company transfers ownership or responsibility for the product to another company, usually a transport company like a pipeline, shipping vessel, or other company. Qualities of a hydrocarbon product can vary, so it's measured for volume, mass, chemical components, and BTU value. BTU value defines the product's energy content, which in turn is used to calculate the cost of the selling product to the end customer, depending on market value. Both companies will have similar instrumentation to take these measurements, and the results must match to a very low tolerance for error. Your company depends on the measurement technician to keep the instrumentation calibrated and working properly, and is therefore one of the most valued employees of the company. That's all the time we have for this section, and we'll see you next time. Thanks for watching.